In this lesson, we're going to talk about the integral of tangent x dx. So what do you think we need to do in order to integrate this function? The first thing we need to do is convert tangent into sine and cosine. So you need to know that tangent is sine divided by cosine. So now how can we integrate this expression? We need to use a technique known as u-substitution. We're going to make u equal to cosine x. And du is going to be the derivative of cosine, which is negative sine x times dx. Now at this point, what I like to do is I like to solve for dx, so I'm going to divide both sides by negative sine x. And so dx is equal to negative du divided by sine. Now let's replace cosine x with the u variable, and let's replace dx with negative du over sine. So we're going to have the integral of sine x divided by u times negative du over sine. So now we can cancel sine x. And I'm going to take the negative sign and move it to the front. So this is going to be negative integral 1 over u du. What is the antiderivative of 1 over u? The antiderivative of 1 over u is the natural log function, ln of u, plus c. Now our next step is to replace u with what it equals. We set u equal to cosine. So right now we have the natural log of cosine plus c, but we have a negative sign in front. Now, we don't need to leave the answer in this form. We can adjust it. A property of logs that you need to know is the power rule of logs. For example, let's say if you have ln x to the fourth. This is equal to 4 ln x. So you can move the 4 to the front, or you can move the 4 back to the exponent position. And that's what we're going to do in this example. Right now, we have a negative 1 in front of the natural log expression. And so we're going to move it to cosine. So this is going to be equal to positive natural log cosine to the negative 1 power. And so that's equal to the natural log of 1 over cosine. Now, what trig function is equal to 1 divided by cosine? It's one of those reciprocal identities that you need to know for trig. 1 over cosine is secant. So this is the natural log of secant x plus c. And so this is the integral of the tangent x function. It's ln secant plus c. Now for the sake of practice, let's find the integral of cotangent x. Feel free to pause the video. Follow the same procedure to integrate this function. So first, let's convert cotangent into cosine divided by sine. And then let's use u-substitution. So set u equal to the part on the bottom. That is sine in this case. So du, the derivative of sine, is going to be cosine x dx. So solving for dx, it's going to be du divided by cosine. So let's replace sine with the u variable, and then let's replace dx with du over cosine. So we're going to have the integral of cosine x divided by u times du divided by cosine. And so we could cancel cosine at this point. And so this becomes the integral of 1 over u du, which is the natural log of u plus c. And then u is equal to sine. And so this is going to be ln sine x plus c. Now we don't have a negative sign in front, so we don't need to modify this expression. So this is the integral of the cotangent function, the natural log of sine x plus c. And so that's it.